Good day, everyone. In 9.2, you learn of applications of trigonometric ratios to find unknown sides of right-angled triangles. In 9.3 now, what happens is you'll actually be looking at applications of trigonometric ratios to find unknown angles of right-angled triangles. Okay, please take some time to fill up the header as shown over here. Now, in this topic, you'll need your calculators as well. So please make sure that the mode of your calculator is in degrees. So over here, it will be DEG in short for degrees. We have three questions over here. Cosine theta equal to 0.876, tangent theta equal to 2.042, and square root 2 sine theta equal to 1. Okay, I will proceed to show you one example of how we'll actually do this via 6a. Okay, which in this case, we have cosine theta equal to 0.876. I'll write down the trigonometric equation first. Okay, so what happens is I only want theta on my left hand side. Okay, but what can I do to actually have my theta on the left hand side when I actually have cosine theta now? So what happens is I will actually be adding a inverse function of theta on the left hand side here. Now, remember your equations, if I do anything on the left hand side, I must also do it on the right hand side. Now, looking maybe from here, I will actually pause for a moment to talk about this inverse of cosine. A lot of you may be tempted to actually state this as cosine inverse, but that is not the correct way of actually addressing this terminology. So a few things that you'll be looking at this on the right hand side. Now take note, this is not called cosine inverse, it is called arc cosine. Okay, same case for tangent and sine before we actually proceed to part B and part C. So when you have this is called arc tangent, and the inverse of the sine function is actually your arc sine. So please take note, we actually name this arc cosine, arc tangent, and arc sine instead of just calling them cosine inverse and the like. Okay, so looking at this now, the left hand side, back to this part. Now, the arc cosine and the cosine will actually neutralize each other, and as a result, our left hand side now will actually be just theta. Now, on the right hand side now, we have arc cosine of 0.876. Now, how do we get this function? Okay, simple. Go to your calculator. Now, this part over here, there are some calculators where you can actually press the second F button and press the trigonometric ratio that you are using to actually get the arc of the trigonometric ratio that we are looking at. So in this case, since you are doing cosine, depending on your calculator, you can actually press the second F button and press cosine, or if you have other calculators like the Casio one that I'm using now, okay, what happens is you press the shift at the top left hand corner, after which you press your cosine. Now in your calculator, it should now reflect the arc cosine function. So key this in to a calculator. What happens is from here you should get a number that is relatively long in the sense of 28.836 degrees when I truncate this in phi SF. Now this is the angle that we are trying to find. Of course, for your final answer itself, we do not just truncate it at 5SF. So what do we do since it's angles? We actually round them off to 1 decimal place. And this is your final answer for this 6A. Okay, simple enough? Okay, we'll move down to our next example. Tangent theta equal to 2.042. So same case, we are actually looking at finding the angle theta. So on the left hand side, if I actually have theta, what happens for me to actually be able to find theta is for me to do the arctangent of 2.042. Key this into your calculator. Your answer should be 63.908 degrees when you truncate it to 5SF. It's an angle, so we actually round it off to 1 decimal place, so it should be 63.9 degrees. Now on to the next example, square root 2 sine theta equal to 1. Okay, before we can actually solve this equation, we need to actually divide both sides by square root 2 for us to be able to use arc sine to solve our equation. So what happens is I have sine theta equal to 1 over square root 2. So from here, theta is actually equal to arc sine of 1 over square root 2. Please be careful when you are keying in the calculator for this particular expression. So this surprisingly gives us 45 degrees. Okay, so I've shown you these 3 examples on how we can actually use our trigonometric ratios to find our angle theta. Now we proceed on to example 7 below. For example 7, please take note of a few factors. Now, all lengths given in the question are in centimeters. And the answers that we actually find, in this case, will be the value of our angles, will have to be left as 3 significant figures if they are not exact. Okay, so without further ado, let us proceed on to the first question, 7A, where you have a triangle ABC. Now, looking at this, it is important for us to be able to identify which are the opposite, adjacent, and hypo sides. So, for this case, hypo will be the longer side, which is BC. Now, for those of you who are not very confident yet, I would suggest that you label the sides accordingly first. Okay, so hypo is actually the easiest for us to actually identify because it's the longer side. Now, next we have AB, and AC. Now, as per how you were taught previously, okay, adjacent means beside. So, the adjacent side will be the AB side. Since AB is actually the side that is beside the angle theta. And the last one will be opposite, which is AC, because AC itself is opposite to theta. So this tells me that this is actually opposite. So for us to find our angle theta, you need to first be able to identify what are the adjacent sides, the opposite sides, and the hypo side. Now, based on this now, looking at the question again, we have information on our opposite side and the hypo side. So, as a result, O and H, what can we use? Yes, you're right. We can actually use sine. So, sine theta is actually equivalent to opposite over hypo. So, in this case, our opposite is actually 9 and our hypo is actually 11. So, to find the angle theta, very simply what happens is theta equal to arc sine of 9 over 11. Key this into the calculator. and your answer will be 54.903 degrees, truncating it in the terms of phi SF. So the question requires us to leave our answer to 3 significant figures if the answer is not exact. So as a result, we have 54.9 degrees 3SF. Okay, simple enough. Moving down to B and C. Okay, at this juncture, I would like for you to actually pause the video for a while. Give part B and part C a try before you continue playing the video so that you can check your answers and make sure that you are on the right track. Looking at 7B now, we have information of triangle ABC with the 5 and the 12 given to us. Notice the 5 is actually the opposite of the angle theta, and the 12 is actually the adjacent of the angle theta. So what happens here is we have the opposite, we have the adjacent. So yes, you're right. Tangent theta will be equivalent to opposite over adjacent, which is actually equivalent to 5 over 12. So for us to actually be able to find angle theta, all we need to do now is use arctangent 5 over 12. So this gives us 22.619 degrees, which is equivalent to 22.6 degrees given in 3 significant figures. Okay. Looking at 7C now, okay, we have AB, which is the adjacent of the angle theta. AC in this case is actually our hypo. Now, if you have difficulty trying to identify the adjacent, opposite, and hypo, okay, what I can advise you to do is at times turning the diagrams will actually help you to identify the sides a bit more easily. Yeah? Okay, so we have information on the adjacent side and the hypo. So in this case, A and H, we should be using our cosine theta. So cosine theta is actually equivalent to adjacent over hypo, which is equivalent to 10 divided by 14.5. So theta will actually be equivalent to arc cosine 10 over 14.5 . So this gives me 46.397, which is degrees, which is equivalent to 46.4 degrees given in 3 significant figures. Okay.